Okay, graphing quadratic functions. Guys, there are a few things that we need to talk about. Just first, some vocabulary. First off, a quadratic function, you'll remember, is any function where x is raised to the second power. That's the highest power of x. If we had an x cubed, then it'd be a cubic. But the highest power of x is x squared. All right. So that means that it's a quadratic. You know, we won't even necessarily have that stuff. Sometimes we will, right? And we can, but y is equal to 2x squared. That's a quadratic, even though there's nothing behind it. There really is. It's plus 0x plus 0, right? We can make it look like the form that we have right here, okay? But it doesn't have to have a b or a c that's something other than 0, all right? Now, the graph of a quadratic, whenever we graph it, the graph of a linear function is a line, but the graph of a quadratic is always a parabola, which looks like a U, kind of. But a parabola never turns over on itself. It continues to expand outward. Okay? The vertex is the highest point of the parabola if the parabola opens downward, or the lowest point of the parabola if it opens upward. Okay? And that's also called the maximum or the minimum point of that graph. Okay? And then the last term is the axis of symmetry. I'm just going to draw a little sketch of a parabola over here. Okay? If this were the parabola, right? Parabola is symmetrical. There's a line that cuts it directly in half, and that's called the axis of symmetry. And it's a vertical line. So we know its equation is going to be x equals something. Okay? This point is called the vertex. And it's going to have an x and a y. And the axis of symmetry is always x equals whatever the x coordinate is, whatever that number is. Okay? All right. Now, let me get this out of our way so we can see a little better. Okay? 3 things that we need to do when we're graphing a quadratic. And we're going to use a table of values. There are other things, there are other ways that we can graph a parabola or the quadratic equation. But this is going to be the first one that we talk about today. All right? First thing we have to do is we have to find the x-coordinate of the vertex. All right? And we always, to find the x-coordinate, we always use minus b, whatever it is. Here's b, right? If there's nothing back there, then it's just going to be 0, right? But if there is a b, it's going to be minus b over 2 times whatever a is. That little fraction will give me the x-coordinate. Well, that's pretty cool, Mr. C, but how do I find the y-coordinate? Just plug it in. Plug it into the quadratic, and it'll give you the y, because it says y equals. Okay? The second thing we do, we're going to make a table of values, all right, with 5 x values, 5 of them. All right? 2 of them are going to be to the left of the vertex. 1 is the vertex itself. And then 2 are going to be equal distances on the other side of the vertex, to the right. Okay? Now the y values on the left should be exactly the same as the y values on the right because it's symmetrical. Okay? And then the last thing, number 3, plot the points and connect them and make a smooth curve of the parabola. All right? Now, an important note down here just before we get started, all right, is that if a is positive, then the parabola opens up. If a is negative, right, then the parabola opens down. All right? So we're always looking at a to tell us which way this is going to go. But if we plot the points, if we get the points correctly, it should do that for us. All right? But then you'll know if you've done it right. Because before you even start, look at the number that's in front of the x squared. If it's positive, you know the graph's turning up. If it's negative, you know the graph's turning down. All right. Were you guys getting nervous? You saw the red line going.